Okay, let's explain a quick few factoring problems here. To begin with the concept, what if we have something like 12x to the fifth minus 20x to the fourth plus 8x squared? And we said factor that. I know that looks like a 7, that's a 2. Okay? So first thing we're going to do is look at the numbers. Well, a 12, a negative 20 of an 8, I think a 4 works nicely. Fifth, fourth squared, they all have at least a squared. So I'm going to do 12 divided by 4 is 3. 5 take away 2 is 3. Let's double check. 12x to the fifth, good. Minus 20 divided by 4 is 5. 4 take away 2 is 2. Double check. Negative 20x to the fourth, check. 8 divided by 4 is 2, and we're good. Okay, are we all set? So that's factoring out a greatest common factor. Not a problem. It's easy, but you're going to use that concept a few times. Let's go on to this for a second. Let's say we're going to do difference of squares, okay? This would be in the form of a squared minus b squared. What that results in is a minus b, a plus b, okay? Comes up a lot. The concept would be simply x squared minus 25 would be the same as x squared minus 5 squared, resulting in x minus 5, x plus 5. If you doubted it, distribute this together, and you'd get this. Another example being x squared minus 49. Well, you're going to recognize that as x squared minus 7 squared, and that would be x minus 7, x plus 7. Done. X squared minus 81, x plus 9, x minus 9, or x minus 9, x plus 9, doesn't really matter. Okay? Now what that turns to sometimes is a little bit more ugliness. Let's say we have something like 4x cubed, I don't know, minus 16x. Well, you look at that and you're like, that's not the same rule. Nothing squared. But remember what I said to begin with. If you can factor something out, clearly it shares a factor of 4 and clearly an x. Well, that must be x squared minus 4. Let's double check. 4x cubed minus 16x. Well, right here is hidden a difference of squares. You with me? So 4x is the original factor, x minus 2x plus 2, and we're done. Okay? Now the last example I'll give you of binomials would be something like this. 9x squared minus 16. That again does not look quite right, because you're like, well, that's not fitting the mold. But this is really hidden as quantity, 3x squared minus 4 squared. 3x squared, isn't that really 3x times 3x? 9x squared minus 4 squared. 3x minus 4, 3x plus 4, and you're done. Okay? So, what else this turns to? That's good for binomials, or difference of squares. Always difference, not sum for right now. Okay? If you're lucky, later on I'll teach you sum and difference of cubes. That's just if you're lucky. So let's try something more common, quadratic trinomials. Now the method I'm going to show you, everyone has a different way they do things. You might have some teachers that say, that's too slow, and it's really not fast, I'll admit that. But it's very clear, and if you go step by step, you're going to get it. As you get good at this, you can kind of do it in your head with some other methods, okay? So let's say I give you an example like 5x squared plus 11x plus, let's call it 6, okay? We're going to start off by identifying our a, b, and c. Well, clearly that's a, clearly that's b, and clearly that's c. Don't mess up. Just do what I just did. Now, a times c is 30. B is 11. Okay? It's really that easy. Now we're going to think of what two numbers multiply to be 30 that add to be 11. Well, I mean, you can list down your options. What if you say 3 times 10? Yep, but they don't add to be 11. Nope. What if we say 15 times 2? Yep. Nope. What if we say 10 and 1 is 11, but nope. You get the idea? So you're going to think and come up with 5 and 6. Well, 5 times 6 is 11. 5 times 6 is 30. 5 plus 6 is 11. There we go. So what we're going to do now is kind of rewrite our original trinomial. 5x squared plus 5x plus 6x plus 6. You could have changed the 6 to here and the 5 to here, but what's the point, really? Really, what you're just trying to see is 5 and 6 make 11. Okay? Now, when you get to 4, split them. Do it always the way I'm describing, and it will work out fine. I'm going to take out a 5. I'm going to take out an x. X plus 1. If it's in here, you put it in here again. What's left over? That must be a positive 6. Let's double check. 5x squared plus 5, 6x plus 6, we're good to go. Factor out what's in common. What's remaining goes right here. You're done. X plus 1, 5x plus 6. If in doubt, multiply it back out together, and you get the original, and you know you're good to go. Okay? Let's try another one. What if we have something like 4x squared plus 14x, I don't know, minus 8. 32, okay, that works out fine too. Now, I could say negative 32 and 14 and go from there. But, remember I said earlier, if you can factor something out, please do so. It'll make it easier in the long run. I can't take out a 4, but I can take out a 2. X squared plus, that'd be a 2x squared, my apologies. So I get 4x squared, I get 7x minus 4. Let's double check. 4, 14, negative 8, we're good to go. Do not forget this too, we're going to use it in a second. 2 times 4 is negative 8, and I get a 7. And I think 8 and a 1. Well, 1 has to be a negative, must be that, because 8 take away 1 is 7. 8 times a negative 1 is negative 8. So we're doing very good here. Correct? Okay. So, just like I said, I'm going to take this and rewrite 2x squared, this guy stays out here, plus 8x minus 1x minus 4. Again, if I flip these around, it means nothing. Okay? I split it down the middle, factor left, factor right. Well, if I factor left, I take out a 2x, x plus 4. 2x squared plus 8x, check. What lives here? Really likes living there. This must be a negative 1. 2x minus 1, x plus 4, we're done, except the original, 2. Later on when we solve by factoring, we'll negate that, but for right now we'll keep it. Those are the factors of that original quadratic trinomial. Okay? Now sometimes you're going to have a gift. I mean, this way works every time the leading coefficient is not 1. Okay? Sometimes you're going to have something like this. X squared plus 5x plus 6. And you're going to be so thrilled when this happens. When the leading coefficient's 1, all we need are magic numbers. So 1 times 6 is 6 and 5. And you're going to do this in your head, guys. You really will. 2 times 3 is 6. 2 plus 3 is 5. X plus 2, x plus 3, we're done. It's that easy. When the leading coefficient's 1, don't do all that other junk we did before. Just look at it. And again, as you get better at this, you'll see little tricks and speed up as you need to. Okay? Okay, so another one. Let's try x squared. Let's say, I don't know. Let's say 7x plus 12. Well, I look and I'm like, 1 times 12 is 12. 7 must be a 4 and a 3. X plus 4, x plus 3, done. They add to be 7. They multiply to be 12. Oh, sorry. What if I do x squared? I don't know. 13x plus 36. Okay, and we think, what could it be? 18 and 2? No, that didn't work, right? So I think a 9 and a 4 maybe? Let's try it. 9 times 4 is 36. 9 plus 4 is 13. We're good to go. And again, to check it if you have to, x squared, 4x, 9x, 36, 13. We're good. Okay? Just going to have one more minute here. Oh, I don't want that. Sometimes you have situations where you might have something in the form of 100x squared. Let's call that a 49. Let's call this 140. And you're like, there's nothing I can take out. And it looks terrible. Could you do A times C and sum of B? Yes, you could. But you're going to look for a little trick. If you remember back, you had a teacher at some point, I'm sure, that said something like this. A plus B, quantity squared, equals A squared plus 2AB. I'm off the paper, plus b squared. Okay? And what that means in words is square the first, double the product, square the last. I'm sorry, I didn't mean to write that. So I square the first, double the product, square the last. And that's in the form binomial squared. An example being, what if we had x plus 3? I'm going to follow the rules. Square the first is x squared. Double the product, 3x double the 6x. Square the last, and that's 9. Okay? And if you did the math out another way, you're fine. You could write x plus 3 twice and distribute. Okay? So we're going to work backwards. Do you see how this is squared and squared? Look right here and here. 10x. Square root, right? 7. That sign, drop it, squared. You're done. It seems crazy easy. And it doesn't happen often, but sometimes you have this perfect little situation. Let's try it. Square the first, 100x squared. The product is 70x doubled. Yeah, we go. Square the last, done. Okay, let's try another one. I'm just making these up. I didn't prepare too much for this. So let's call it a 7, 9, 63, 126 done. Okay, let's do something like this. Okay, 49x squared, 126x plus 81. Does it fit the routine here? Let's see. Does it look like it's something squared and something squared? Two perfect squares. Let's try it. It's quicker to try it and fail than to go through ACB method or something like this. So 49 square, isn't that a 7, right? 7x. Positive. Square root. 9 squared, done. Let's see if it works. Square the first. The product is 63, double the 126, check. 9 squared, 81, done. 7x plus 9 quantity squared. You could write it out twice, but that way works fine too. Okay? So let's say we have something like this. This will help you a little later down the road, but what if you have, I don't know, 100x squared plus 9, 10, 3, 30, 60. Ready? Let's say that's equal to 4. Let's say 5 to make it hard. Okay, so we're going to go bang, bang. We're going to say, yeah, it looks suspicious here. That must be a 10x. Positive sign, drop it. If it was a negative, drop it there too. Square root 3, squared, let's see. 100, 30, double the 60, squared 9 is 5. Ooh, that worked out great. Square root, plus or minus root 5, minus 3, divided by 10, x equals, done. You just solved the quadratic trinomial by method of factoring, and it saved you tons of time if you had to do quadratic formula. Okay, that's about it. Good job. Have a good night.